Alright, I just want to do a quick walkthrough of the Open Transaction software. You can see we're in the main folder here. There's the library. The bulk of the Open Transactions project is just a software library, a bunch of C++ objects. And then there's also a server, which is built with that library. And there's also a client built with that library. On the client side, I have just a normal command line, which I'm trying to improve to make it to a real Unix style command line. And then we've also got a Java client, which is a GUI, Java GUI client. So the first thing is, let's start up the server itself. So now that's running. And next we'll start up the Java GUI. You got to tell it where the data is. On the client side, the test wallet folder here is called data folder. And that's it. The Open Transactions distribution comes with a test nym, and so this is just, the password is test for the test nym. So let's go ahead and go to the nyms tab. So there's the fellow travelers test nym. Not much to see really. You can see that nyms kind of have this little email system where a nym can send messages to other nyms on whatever server that you're registered at. This isn't really, my goal to replace the email system or anything like that. It's more that the nyms in general have a process where they receive transaction numbers and sign for them, and that nym box, which is a sort of an inbox where a nym can receive transaction numbers and sign out that number to be responsible for that number. So that mechanism has to be there just for the way that Open Transactions works with all its core account system. And so it's kind of an afterthought to throw email ability on top of that. But it turns out that this is actually pretty useful for, sending checks back and forth or sending invoices or whatever. And so let's go ahead and create a new nym. A nym is basically like an identity. It's just a public key, basically. So I'm going to make a new nym, Trader Bob. And, this is like creating a key on your computer. I haven't actually registered him at any server. So in fact, let's go ahead and register this nym. Of course, the only server I have right now is the one that's running on the local host. So he's been registered there. So now if we go over back to Trader Bob again, you can see this time he has a request number. He has a request number for that server. So we can see he's registered there, got a request number. The request number increments with every message, and that's what prevents someone from intercepting a message and sending it multiple times. So let's see, contracts. There's a server contract, as I touched on previously. So Open Transactions right now just comes with a test contract, which is a localhost server contract. Basically, it expects a server to be running on your local host. It expects that you're running the server, just like I am right now, just for testing. So you can see it says localhost inside the contract, and there's the port. So the idea is that the connection information is located inside the server contract itself. And you could have maybe an I2P address in there, a Tor address, whatever. There could be 30 different forms of network protocols listed in there, different addresses in there in a single contract. And so whenever I do any action that involves a certain server contract, then Open Transactions is smart enough to load up that contract and get the connection information out of the contract. Now assets are also issued via contract. So you can see this is a test contract that I made. I called it Silvergrams. Obviously there's no real issuer for this contract, it's just for testing. And you can see it's just a XML file. It's got information about the currency, stuff you'd want to know, in the software when you're writing software for this sort of thing. It's got legal terms, may come up in court. And then whoever is the signer on this contract, whoever signed this signature here, he's got his public key inside the contract. And the server should be able to take the public key out of the contract and use it to verify the signature on the contract. And so the contract's self-verifying. And also if you take the contract and hash it, put it through a hash function, then you'll get the ID. And what that means is that the contract's ID will be consistent across all servers. If you take the same contract on a computer in China somewhere and hash it, you'll get the same ID. And if someone changed this contract by even 1 bit, then you put it through the hash function and you'll get a different ID. You can't change the contract without changing the ID. And so it's just part of the security. It's like the fingerprint of the contract. Now let's say that I want to issue another currency onto a certain server. So I'll just go find the contract that I made, which in this case is going to be Chuck E. Cheese game tokens. There's a tokens contract. So we'll open it. So you can see there's the game tokens contract. And I'm the signer on this contract, so I should be able to issue it at any server. So let's issue it. We'll choose the server. Of course, there's only one right now. And we have to choose the correct NIM that's the signer on that contract. And boom. So now the asset has been issued on the server. So now I should be able to go open accounts in game tokens. In fact, there should be an issuer account here. And there it is. So I'm just going to edit that. I'm going to put issuer game tokens. Alright, and here's Fellow Travelers test account. Let's just rename that too. We'll call that Fellow Travelers Silver. Now remember, we made this new NIM here, Trader Bob. So Trader Bob should be able to open a silver account or a game tokens account, whatever you prefer. Let's go ahead and open a silver account. So we'll call this Bob's Silver. Choose the Bob NIM on that server and the silver grams asset. And now Bob has a silver account. And so the issuers always start at 0. Like notice the game tokens issuer started at 0. And so when an issuer transfers money to someone, then the issuer goes into the negative. The issuer can only go in the negative. So let's say this issuer transferred out 1 million game tokens, so he'd have negative 1 million, and then the recipient would have like positive 1 million. And if you gave them all back again to the issuer, it would just go back to 0 again. It should always equal 0. So if you were to take all the game tokens accounts and add them up together, and then add it to the issuer account, it should equal 0. And that's what we see here with silver. This silver issuer has issued, was that 100,000 grams of silver? And so all the rest of these should add up to 100,000 grams. Now let's go ahead and transfer some silver to Bob's new silver account. Whoops. We'll do a transfer. Send transfer. Transfer to Bob. Let's do 100,000 silver grams. Okay. Now, the way Open Transactions works is transactions have to be signed for. So if the issuer, for example, wants to send some silver, he has to sign to send it. And you can see it's in my outbox, pending, because now Bob has to sign to receive it. So I go to Bob's account here, in his inbox. You can see there's a pending. Of course, the money already came out of the issuer's account. See, it's negative 200,000 now instead of negative 100,000. So the money came out of his account, it goes into pending. He had to sign to send it, and now Bob has to sign to receive it. So I'll sign to receive it. Now, at the time that I sign to receive it, I make up a little slip saying, hey, here's a copy of this thing. I'm signing to accept it. And on that same receipt, I put a copy of my inbox, and I also put my current balance. And I also put a list of the transaction numbers that are currently signed out to me. And then I sign that, and then I send it to the server, and the server signs it and sends it back to me. And then that's my receipt. So I'll process it here. And then my account balance should go up by the 100,000 grams from accepting that transfer. So you can see now I've got 100,000 grams in my account. And so on my receipt, I've got proof of my current balance. I've got proof of what transactions are signed out to me. I've got proof of the items that are in my inbox. And the server can't change any of those things because the server can't forge my signature on the receipt. So the server can't change my balance, for example, because the server can't forge my signature. And the balance is just whatever's on the last receipt. Now, you can see there's some instruments here You can write a check, deposit a check, a voucher. That's kind of like a cashier's check, or what they say in England, they call it a banker's check.